All right, so we are at exactly 11:30 on the dot, and we are about to kickstart this ecosystem talk. Hello, everyone. My name is Robert Wolf, and I hope you are all having a great day 3 at the ARM Dev Summit. It's been a lot of fun. Me personally, I've gotten to see a bunch of really cool stuff, and the keynotes have just been great. This talk is about the HoneyComb. Empowering native ARM development with a standards-based workstation hosted by John Nettleton from SolidRun. There are, of course, a few other folks from ARM that will be here in the call, along with John, our speaker. We will be taking questions, and hopefully, if you feel so inclined, you can unmute and join the conversation yourself. The call will last 30 minutes, and we will have a hard stop at 1 hour. So that being said, if you have another session to go to at the 30-minute marker, please feel free to go to that call or the next session. If the conversation is vibrant and engaging, we do plan on continuing until the hard stop at 1 hour. Now, after I'm all done with this, we're going to pass it over to John Nettleton. But for those of you who do have questions, I did mention you can, one, unmute your microphone and join the conversation and or ask your question. 2, you can post your question in the chat. We will be monitoring the chat, myself, several other folks here. Or 3, you can DM me directly and I will ask your question anonymously. So without further ado, I'm going to pass you on over to John Nettleton. John, thank you so much for doing this call with us. The mic's yours.
Thanks a lot, Robert. Hi, everyone. It's great to be here. And as Robert said, if you even want to preload the chat with some questions, go right ahead. I'm just doing a brief overview and to talk about a few specific points. But overall, it's just to basically talk with the community and also get questions and be able to answer some specifics. We've already done a few videos on HoneyComb. You can find those on the ARM developer channel, software developer channel, and also the SolidRun channel, where we go into some more specifics. What this talk is focused on is how and why SolidRun created the HoneyComb, and specifically why we sought out for the system ready standard, or at the time it was the ARM server ready standard, and how we worked with ARM in order to move towards and define the new system standards that are defined and announced in this developer summit. So just a quick rundown in case you don't know what it is and you saw, oh, HoneyComb, I'm going to join. HoneyComb is the 16-core workstation / micro server grade ARM 64 board. It's Cortex A64s. It supports up to 64 gigabytes of memory, has PCIe X8 slot, NVMe slot, multiple SATAs, all the goods. Mine's sitting over here on the behind me, which is my primary workstation, by the way. And this board is a year and a half ago. NXP came to us with the chip. And this was right after Linus said that ARM in the cloud is never going to work until ARM's on the desktop. And NXP had come to us with this new chip, the 16-core chip. We'd done initial testing on it, and it was really good, worked great. We talked with NXP, and we said, well, is it SBSA, SBBR compliant? Because if we're going to do this and do something with it, we really need those standards. We've been working for a long time on, We've been working a long time on various other platforms and looking at the server market, or at least the edge market at that point is what was coming up and more what we were focused on at SolidRun. And we were like, okay, well, we need SBSA, SBBR. NXP said, yeah, it should be fine. And I think this is the story that has kind of plagued SBSA, SBBR for the previous 8 to 9 years was, okay, not quite. But at the same point, ARM had actually reached out at that point And we kind of got pulled into this new movement that ARM was kind of doing behind the scenes, which was, instead of just saying, okay, it's not going to make it, throw it out. This is just another failed SoC that's not going to meet the standards and we have no use for it. We had a very open discussion about, well, we're mostly there. And I think, and Andre at VMware was kind of doing the same on some of the other chips that he was working on. And we kind of worked into this. Well, what are the standards and what are they meant to accomplish? And basically it is to let it boot up and work like a PC. And maybe we can't check all the boxes, and that's where the levels came from, but we can check most of them and it's still useful and functional. In the ideal world, everything would be perfect in the silicone and this would all work and there wouldn't be a problem. But obviously the world's not perfect. And so we started on this path working with ARM and NXP and taking what we had as hardware with great potential and turning it into an actual platform that's getting closer and closer to a turnkey solution. And obviously, we're not 100% system ready certified yet. We're just right there. We're just doing paperwork, but all our tests are passing and the hardware is there. And we have it so we can boot Windows, VMware, multiple Linux distributions, BSDs. It basically works out of the box as expected for the components covered under the, well, I should say BBR now and BSA. So why go through all this hassle? Why did we do this, you know, as an ODM? And that's kind of what I want to touch on here in this talk. And the piece is, especially when moving to the edge and bigger heterogeneous environments, the path that we were on with our boards was becoming too hectic to be productive. As an ODM and an OEM, what we want is we want to get our hardware into the hands of the people building the products so they can do whatever they want with it, create the product that they want to sell and get it out the door. That's how we make sales, and then we can move on to the next cooler thing, but we still need to maintain it. Having to maintain all these individual bootloaders and kernels and patches was not just time consuming and starting to limit where our products could go and the new cool things we could help customers work on. It was also at some point defeating the purpose of being able to service every customer. Because we come up with a new BSP and it's either Yocto or Debian or something just to get a customer up and running. And the first question that we get is, well, can I run Ubuntu on it? Or can I run Fedora on it? Or can I run Gentoo on it? And you can't maintain every distribution as an OEM or an ODM. It's just not possible. You have to pick and choose. And of course, you want to build a community and to work around it. But overall, getting that base booting portion taken care of at a firmware level that can be brought across all these platforms, and not just open source Linux distributions, but the power of this is we have Windows 10 Enterprise now, and we have VMware who are also working and leveraging the same philosophy and the certifications in order to bring their products to run on the hardware. And this is great. I mean, and so what we then took on in order to do this was working with ARM, working with NXP, worked with another company called Pure Software to pull together the Tiano core base for UEFI, figure out all the little hardware quirks and bits that were missing that were specifically needed for our board, and start to pull these pieces together into fully open source firmware that could be certified under the BSA and BBR under the new system ready standards. And we are working on the more advanced pieces in the certification as well. Some of the RAS stuff. We are working to do firmware first error reporting for PCIe, expose ECC error checking and those sorts of things in a firmware first mode. And these are things that haven't really been done before. So we're able to kind of push the envelope as well with the hardware we have. So what does this mean for developers and why is it important? Now that we have it here and we're starting to build a community. As far as I'm concerned, what this means is if we don't want developers developing for ARM, we want developers developing on ARM. Because the way I see things and perceive things is you can know everything about a system, and I've been working in embedded and networking devices for many years now. But unless you're actually sitting in front of it and working on it in and out every day, there are things that you just don't see. And it's a nuance that you get working on a computer and working on an architecture versus just working on something else and then pushing code and running it for a specific application. Just general use cases that you won't hit because everything's being done in a very controlled environment. The system that's on it, and that's well and good, and it's been working for us for many years, but it has I believe it's left things on the table performance wise and those sorts of things that will benefit ARM down to the small edge, at the edge, up to the cloud, on the desktop, just all around. There are places where we can do better, and the only reason we haven't is because people aren't using it on a day-to-day basis as their main machine. And with the new systems ready standard, we have we have the Pi 4 now, which is it's great that that's available, and it's great for people who want to just grab something cheap and bring it up. And but I think, and why we call it a workstation, is we want to push that next level of what can ARM do, which isn't going up to the $3,000, $5,000, $10,000 servers with 96 cores, and it's sitting in the corner of your office and it sounds like a tornado is going around. And that's where we really see the HoneyComb and the LX2168 fitting really nicely. You can have your PCIe, you have USB 3, you have your SATA, 4 disks for storage. So now, and 16 cores and up to 64 gigs of ECC memory. So you can partition that down to 4 VMs of 4 core, basically 4 Raspberry Pis if you want, with even more memory, twice the memory. And you can actually test out things that are the next level, OpenShift and Rancher, Kubernetes, run VMware ESXi on it, and actually run like real VMs, and that can handle the bandwidth. And we feel that with developers who are interested, and I know people look at the hardware and they're like, oh, it costs too much, or they're too spoiled by the nukes, or they just want to play with it and it's too much money. And we see HoneyComb as a tool, and it's not something that we're like, everybody should buy, this is the new Apple or whatever. This is a tool for serious ARM developers or people who want to get into the ARM ecosystem at a level that's above the single board computer and get into it in under the $1,000 price point. And we feel it really kind of hits those marks. So that's where we are there. Any questions right now, or can I move on to some other pieces? Anybody?
No questions have popped up in the chat just yet.
Okay.
But yeah, I would like to encourage anyone who does have questions for John to feel free to type in the chat or speak up.
Okay. Well, I will keep talking. I have no problem with that. Okay. So what are the next steps, and where are we going, or why is this, or why what we have achieved is important, or why we feel it's important? I feel it's important because the server ready, previously the server ready specification was this unicorn that the ARM community seemed to be chasing, and there were lots of backers and pundits who were very excited about it and were pushing it and being adamant about it, and to the point where it became something that was so rarely achieved that it became almost it became to the point where it's like, well, why bother? And I think with what we've accomplished with the Raspberry Pi and the HoneyComb at two different levels that are lower end, is we've provided those first steps to start gaining momentum, so the silicon vendors can see the benefits, and the people and the developers can see the benefits about why it's important, and why maybe you should spend a little money to have more money to have a platform like this. Not that it's a must-have, but now you do have the opportunity where you're not losing time. Oh, I've got a new board. I gotta go get the bootloader for it. Okay, which kernel, which branch do I need? What am I doing? Is my distro supported? Instead, they can the board can show up. They can, if firmware's not on it, they can load firmware on it, and just grab off the shelf Fedora, or or start building Gentoo if they want, or, oh, I want to try out ESXi, and it will mostly just work, or it will at least boot to the point where you can start working on the specific things that aren't available. I think one of the pieces that's really illustrated with this, and why it's important, is now we already have a thriving community using HoneyComb. I think once people started getting boards, we had people helping out where it was basically booting. Not everything was perfect, but we had people writing blogs for how to use Ubuntu. Within a week or less than a week, I think, various BSDs were getting patches in order to add support or things that weren't working quite right, or little bugs we turned up, and then they were working. And then with ESXi, things kind of were moving smoothly enough that, Andre just moved off and could focus on his Raspberry Pi firmware and the work he was doing there, which was fun. And then as things came back around and certification came back around, everything was just working, and so we were able to move forward and kind of take part in this presentation here and the developer summit.
John?
Yep.
I would like to bring a question forward here from Marcin.
Yep.
He asks, how goes updating the website with UEFI status, etc.? I know that it is in progress, but he thinks it's stopping people from buying it.
Okay. Well, I mean, we're actually reworking. So part of what we were waiting on was actually getting the certification. But we're actually updating our website now and our image server backend. So we will be updating the specs and adding more information about the HoneyComb. Now we're at the point where we're very comfortable with the evolution of it and where it is in its life cycle. I understand the documentation is important, and we are working on it. It is 2020 though, so things seem to take a little bit longer than usual.
It's not even about having full documentation, but there is a huge amount of hardware on the market, different SBCs, etc. And you go to HoneyComb website and you see UEFI work in progress, U-Boot work in progress, etc. So for some people expect, I want to buy something, especially when, for me, for example, I upgraded my x86 machine instead of buying HoneyComb.
Mm-hmm.
So I go there, and if I have to spend money on it, I want to know that it will not be yet another SBC where I have to wait for mainline kernel, for bootloader sources, for UEFI sources, for anything that I will get it, will boot into some random bootloader, random build of firmware, and we'll have to wait and wait until it will be finally working, stable, and upstream. So having info that I go to website and there is information that here UEFI is working, and here you have a link to latest test build with some short instruction how to install it on board you just took from the box will be helpful. Small, simple steps for starters. I take your board, I unpack it, and how I get latest firmware running on it, this kind of stuff.
Well, I think some of that is, so it's a very valid point. And I think part of that is the difference between, and it's something we can work on, where the product page is different than our developer knowledge base. And that's probably where some of the, and we do need to update the UEFI information as well. Most of that has just been pushed within the last couple of weeks, because obviously we've just reached certification. But I do understand. So it's something I will take back and we'll discuss it, ourselves. Now, and again, one thing I will say is that HoneyComb is a developer board, right? It's now where it is closer to a finished product than most developer boards. It is showcasing, it's enabling developers and showcasing our CEX7 module, which is really, what we want to push. Okay, but thank you a lot, Martin. It's noted. Okay, so
one thing you should more, from marketing point of view, press more as HoneyComb as a workstation than HoneyComb as developer board. For many, sure, you will have many clients who will buy it as, let's check what your COM7 module can do, because they may, for example, have own ideas for their hardware for this module. So they will buy HoneyComb, they will check how it works, then they will design their own carrier board and just buy modules from you, right? For them, it's developer board. But for a lot of ARM software developers, it's workstation. They don't care about how hardware is done, right? They unpack, they put into case, add memory, NVMe, graphic card if want, and they boot into SBB, they boot it as SBBR machine, they install any Linux or BSD or Windows and just use it. They don't care how some people will use it as developer board. For them, it's workstation.
Yeah, we understand, and it's something that we do want to get. Let me just say, there are some plans in the background to make that easier, because it is one of the things that we have dealt with the community. But part of that's also, and today I was talking with Peter Robinson, and he got his board, and he's like, I haven't built a PC in 15 years. What am I? what do I need to buy? And I think that's something that we want to community source a little bit better, the information of what people have used and tested and what's available. And then, you know, hopefully maybe we'll have something that's a little more out of the box developer friendly in the near future. So thank you. Let's see here. So
John, I would just, this is Imran, I would just say to Marcin's point around the distinction between a dev platform and a workstation with an ATX form factor, that's totally 100% agree that we need both.
Mhm.
And for the latter, we are very close to announcing this with SolidRun. So I know that there's a desire to know when that will be available. It is going to be very soon that we're going to announce the availability of a complete, fully packaged developer platform from SolidRun, and details, hopefully will be coming here within a matter of a few weeks.
Yeah, and speaking of full works, selling it as full the workstation stuff, it's also one of the things which I sometimes remind that many people will really want to buy just mainboard, because, for example, if I ask there is some price point where when I ask my manager for permission to buy hardware, there is a certain price point where the answer is go and buy. So, for example, and there are several companies like that. So when you can buy just mainboard and then buy NVMe and memory and case separately, there is a lot of people who will go that way. Or people who have cases, NVMe's, or memory even floating around.
yeah, of course. But that's the balance, right? Because I mean, Marcin, I mean, we aren't a PC maker, that like what we're working with ARM on is testing the waters and about what we can do for our customers who do want HoneyComb in a workstation format, or they want it in a 1RU format, where we are usually we're dealing with SBCs and those sorts of things, or like a small little box that you just stuff a board into. So assembling all the pieces that are needed for this sort of thing, we aren't Lenovo, we aren't Supermicro or any of the other makers. So it's a learning process. I mean, I like your feedback, and we will hopefully we'll be able to provide exactly what you're looking for very soon. Well, you already upgraded your desktop, so maybe not soon. So on another note, let's see here. So we're coming up on the half-hour mark. How are we doing? Are people still interested? A couple other points I want to talk about.
So I'll just mention this real quick. Yeah, as I put in the chat, we are at the end of the first 30 minutes. At this point, if anyone would like to go out to their next session, please feel free to leave. We don't want to hold you here, and we won't think it's not polite. Go ahead. You can go to your next session. If you would like to stick around, John, yeah, please keep talking. There's plenty of time. We still have another 30 minutes before our hard stop.
Okay, so now that one of the pieces that we talked about was the server ready part, and how HoneyComb is enabling developers, systems ready, sorry, and how it's enabling developers. One of the other pieces that we've kind of jumped off into with this as well is another piece that as an ODM and OEM, we get a lot of customers are always interested in, and that's working with ARM and Fedora to, on their Parsec crypto abstraction layer. And then I will let Mark talk a little bit about it as soon as I first talk about how this links to HoneyComb. And so with HoneyComb, we do have the trusted firmware, and it's something that we're working on. And specifically, the LX2160A has something called that has NXP secure object storage built into the SoC as a place to store secrets. And additionally, on our IMX8M based boards, which we are actually looking to bring to one of the standards as well, the lower IoT Edge standard. That has the soft TPM availability for storage secrets. So now we have two different APIs for our customers who want to store secrets. And that is where Parsec comes into play. And so I will let Mark just speak a little bit about that so you guys can hear it in case you missed the specifics.
Thanks, John. Yeah, so Parsec, we had a few talks earlier this week introducing Parsec project. Parsec is what John described here is an abstraction layer that you can leverage in your application layer. So once you get your system up and running, you get your secure boot, and you're there ready to work on the app level. The scenario that John is describing here, where you might want to deploy your application on multiple hardware with different roots of trust, poses a problem. You now need to develop a connection to these security primitives that is different for each platform. Now, wouldn't it be nice if you were able to abstract those dependencies, still leverage them because you want your secure root of trust, but give a set of APIs to your developers that gives them just the same function to be repeated on each board. So that's essentially what we did. So with Parsec, and with the help of John, and we worked with Peter Robertson over at Red Hat, we're going to finish a 4-part series of videos, or a 3-part series of videos where, we'd introduce the project, and we're going to demonstrate at the end what Parsec is doing. There's going to be code, everything's going to be available, and essentially it's going to do this. It's going to demonstrate the application, secure application running on 2 separate platforms without changing a line of code, leveraging 2 different security primitives. So I invite you to come check out Parsec. It's a CNCF sandbox project. We recently donated it, and we are actively engaging with multiple companies on projects to demonstrate how that comes together.
Yeah, really exciting stuff, and it was great to be part of it. And I think that's what leverages, and these are going to be included in Fedora 33. And what's great is this shows the leverage of, if you have a base operating system that can just boot, this isn't, SolidRun had to integrate this into the BSP for the HoneyComb, then they had to integrate it into the BSP for the IMX8M. This was integrated into Fedora 33 by the Fedora community in Red Hat, and they wrote some applications to use it. And now on 2 different ARM64 platforms, we can leverage it using 2 different storage secret backends. And that's the power of the standardization, where it's not segmented into the, I need to download and install it here and then change it for this here. We can leverage these standards and really take advantage of the benefits that x86 has had for so long, where you can just grab a distribution and run it on a Celeron, or run it on a, Threadripper now, I guess, or something like that.
So just to add one more point to that, Parsec is platform agnostic. So once you have it up and running in your system, it works on any hardware platform, including x86. So this is not just ARM. This is a community-led project that spans across multiple architectures.
Any questions on Parsec from the community? If not, I'll switch gears one more time, unless anybody has any specific things they want me to take a look at or answer.
We have shared, or I have shared 2 video links in the chat. You can go dive deeper into Parsec on the ARM Software Developers YouTube channel, and you can also dive deeper into the HoneyComb with a full breakdown given by John as well. There's a video there too.
So if there's no questions, that I do want to touch base. How are we doing on time? Okay, we're moving fine. So this is a more experimental feature that we added to HoneyComb, proof of concept that we did include on the board because it's another step in the standardized ecosystem that we felt needed to be addressed. And if I can share my screen quick, I will see. That's screen. This one? Yeah, this one. Okay, here we go. And this is what we call a micro BMC that we've built onto the HoneyComb platform. And what this is, it's, as the name implies, it's the smallest amount of chip that we could include, maybe just a touch too small for this rev, but we're working on that, to provide a BMC interface to the board. And we're not talking IPMI or Redfish. That's, as far as in our concept, that's another step beyond where the micro BMC is. The micro BMC is an STM32F042 with 16 kilobytes of SRAM. And we have been working, and people have been asking, oh, what can I do with it? What can I do with it? We are working on, and we have a prototype firmware. It's not quite ready for release yet, but we're making progress. And here you can see the capabilities that we're bringing out with what we're calling Project LIMS. We'll probably find a better name. And this gives you all the BMC functionality that a full BMC would give you, basic BMC functionality, flashing the firmware, powering on and off the device, resetting it, checking the thermals, you know, basically you can see all the little bits and pieces here. I think that covers most of it. But all the base low-level board function that you need to control a device that isn't powered on. And part of the reason that we designed it this way is, and this can be secured down. You can put a secure bootloader and those sorts of things. Where actually there's a secure DFU bootloader you can add to it, and that will make it so only devices that can pass the crypto signature can actually connect to DFU mode, if you're thinking about security reasons. And the concept is especially for boards like we have and for edge devices and microservers, having all the cabling for individual BMCs for every node becomes a burden more than a benefit, just because you basically are designing 2 networks. And this isn't true for everything, but in general, it's much simpler to have a simple IoT edge-like device that's secured down and is managed by however you want to manage your edge device. And it has LTE and wireless whatever connectivity you need for connecting out in case of a failure. and then using stateless micro BMCs to be able to, where you can securely load a firmware on there and not leave it running. So if you, and you can power the BMC on and off when you want, regardless of how the state of the board. But so your firmware is always up to date. It's always loaded whenever the board needs to be accessed or booted, and can be unloaded or reset or those sorts of things. And what this provides is you can have a single device, a bunch of secure USB connections, and they'll provide you a remote console. They'll provide you all the board management functionality. They're all powered by the single BMC aggregator, and all can run independent. And this is, and the reason why we shot small was we think this is functionality that, and we're already talked with ARM about bringing in some of these ideas for how we can make this, possibly make this a standard as well, just because you can take a device as small as an STM32 and some additional stuff and put it on a board and manage an edge device with these sorts of capabilities, or a group of edge devices. And that's, and I know a lot of people have been asking about this, and they want the source code, and the source code or some form of it is coming. We just don't think it's quite there yet, and there's a little bit of more work that we need to do before we can release it. But we're excited about the enthusiasm, and hopefully we'll have some updates for you soon. Any questions about that, or how are we doing? Did we lose everybody?
It doesn't look like any more. It doesn't look like any more questions have popped up. So it's up to you if you'd like to continue. If you have any other topics to discuss, if there's anyone else that would like to bring up any topics. Still roughly 18 minutes left for the hard stop.
No, I think, I mean, I'm coming up on 45 minutes. So if nobody has any questions, I think I'm okay to wrap it up now. I think I've covered everything I want to talk about. Like I said, HoneyComb isn't the solution to everybody's problem, and we don't want it to be. What we want HoneyComb to be is momentum and a tool for the ARM developers who need to use or want to use something like this and make it part of their daily work routine, to find those little bugs, to truly understand and run an ARM workstation that doesn't break the bank and isn't underpowered, but is actually a happy medium, and to make software better and to think of different ideas. We wanted to empower the community, and we hope you like it. I will screen share real quick, because one other thing I announced this on Twitter. I'm Linux for Kicks, and we, in celebration of everything going on, if I can find it. Oh no, oh, there it goes. There's Parsec. Come on. Sorry, it's fighting me. Oh, this one, okay. So SolidRun did announce that in celebration of our upcoming systems ready standard, and working with ARM and the work with VMware and announcing the SXI Fling, we are offering a it's actually a $100 coupon. Our system wouldn't let us do $99 off on the HoneyComb LX2K board and CX7 module together. That's good for 2 months. So it's going to bring the price from $750 down to $650, which I think is a really great bargain, because you're getting you know, a board. You can add as much memory as you need, a lot of storage to it. You get multiple 10 gigabit per second ports. We haven't even talked about that. And it really enables you to push ARM to the limit and see what you can do and see what it's like to run it as a desktop or a microserver or whatever capabilities you need to test and whatever software you need to run and develop on it. Okay, thank you, ARM, for letting us be part. SolidRun was great working with you on this project, and we hope to do many more. You can find us at www.solid-run.com or find us on Discord. Did we already put that up?
Yeah,
Robert?
I shared the Discord, and John,
Okay.
thank you very much for hosting this. Much appreciated. And everyone else who joined. Any last words there, John? Are you good?
No. Thanks for joining, everyone, and stay safe.
Perfect. All right. Yes, everyone enjoy the rest of your conference. Day 3, John Nettleton here from SolidRun, other folks, Mark and Imran, who contributed to answering some questions as well. Hope you all have a good one. Take care. Thank you.
Thanks, guys.
Thank you.
Thank you.
Thanks a lot.